Now, let us start with the different terms to be used in case of wave motion. So, we have discussed there are two kind of waves. One is called as a longitudinal waves, other is called as a transverse waves. So, we have seen that transverse waves, the wave particles vibrates in a direction perpendicular to the propagation. Um, While in a longitudinal waves, the particles vibrate along with the axis of the vibration. So we have seen, so these are the two different kind of waves which are being formed. So one, in this case, the particles are get together along one point and spread it over some region, then get close together, then spread it out over some region. So where they get close together, so that region is called compression. Where they get spread it out, so that region is called rarefaction. So compression and rarefaction is formed in case of a longitudinal waves, while in case of transverse waves, two different parts are being formed. One is called as crest, other is called as a trough. So the upper part is called crest, lower part is called as a trough, and difference between a crest and trough is called as a wavelength. So this is the time which is called as a wavelength. So wavelength is defined as the distance between the crest and a trough. So this is the one part, and then how much height the wave is going to upside or to the lower side, so that is called as the amplitude of the beam. So this is called as the amplitude. So all different terms are being there. Then how many number of cycles are repeated in 1 second, so that is called as the frequency. So frequency is defined as 1 upon time period. So 1 upon time period, how many number of waves are being there. So we know that velocity is equal to distance upon time. So distance is equal to lambda upon time, or lambda into frequency is equal to velocity. So speed of the particles can be found out by lambda into velocity. So this is how we can able to correlate between them. So in same kind of things we can able to observe in the longitudinal waves. So what is the basic difference between them? In transverse wave, the particles of the medium vibrate in a direction at right angle to the direction of the propagation, while in longitudinal waves the particles vibrate to and fro and parallel to the direction of, for example, propagation is along here, so the particles will vibrate along this direction. So transverse waves, in transverse wave crest and troughs are formed, while here compression and rarefactions are being formed. So transverse waves are possible in medium which possess the properties of the elasticity. Means they have got the particles get stretched and come back to the mean position. So they are have a free surface, and they are possible only in solids. So this kind of thing is possible in solid and liquid, not in gases. While longitudinal waves are possible in medium which possess properties of elasticity of volume, that is, they are possible in solids, liquid and gases, but in gases this occurs, this only the wave motion possible. So gases only longitudinal waves can travel, not the transverse waves. So they can be polarized means they can be clipped up or broken up into smaller parts, but longitudinal waves cannot be broken up into the smaller parts. So that in this transverse waves, the displacement travels with the waves. There is no change in the pressure of the medium, but here, since the density of the medium changes, so there will be change in the pressure. So transverse waves can be represented by the sine curve. So this kind of curve is called as a sine curve, while the longitudinal waves cannot be represented by sine curves. They are just simple line curves. So these kind of waves can be represented in ropes, like this kind of ropes, and then the ripples in water. So these kind of things are being shown, and then in the, different waves are, or electromagnetic waves are being formed, while such kind of waves are being formed in gases, in springs and in the sound waves, whatever the sound are being emitting out, so they are called as the longitudinal waves. Now let us discuss important properties of the sound waves. Sound waves, basically, these are the waves which are being emitting, which help us in making the sensation of hearing. So without sound, we cannot able to listen or hear anything clearly. For example, when you hammer a surface of a ball, then some sound is being produced, so that will be listened to us. So that means there is a certain frequency which we can able to listen it out, that is between 20 hertz to 20 kilohertz. So beyond that we cannot able to listen it out. So such kind of frequencies which we can able to listen is called as a audible frequency, while the frequency below this one is called as a infrasonic, and the other above more than 20 kilohertz, less than 20 hertz, are called infrasonic waves, and infrasonic, while more than 20 kilohertz they are called as the ultrasonic beams. Ultrasonic beams. So these are the different beams which are being produced, and so the properties are there. So they are longitudinal waves. They require material medium. So without medium, the sound waves cannot propagate, and then the velocity of sound is always greater in solid. So the velocity of sound is always greater in solid than in case of liquid, and then in case of gases. Okay, so this is the main part which we are going to discuss. So these waves experience phenomena of refraction. So these waves can go for refraction, reflection, and interference. All these phenomena can be exhibited by it, and so such kind of velocity and the speed of sound here is directly proportional to the square root of the temperature. So that means with the effect of temperature, so they are going to get it affected. So next time we will discuss about the properties of the light waves and then their further details. Thank you.